Chapter 10 is about thunderstorms and tornadoes. The driving question is what conditions in the atmosphere favor development of severe convective weather systems. A thunderstorm goes through a life cycle of 3 basic stages, beginning with the towering cumulus stage. This is where cumulus clouds are encouraged by convection to continue growing, and they get to a stage that we recognize as towering cumulus, and we'll look at the details of that in just a moment. If the towering cumulus continues to grow, it produces a thunderstorm cloud, and at its mature stage, that thunderstorm cloud is denoted by updrafts and downdrafts and precipitation, lightning, thunder, possibly tornadoes. And then finally, the dissipating stage is where the downdrafts have overtaken the updrafts. Basically, the energy, the warm, moist air, has been cut away from the storm, and the cloud is dissipating. Thunderstorms are what we call mesoscale weather systems. You might recall mesoscale means that it's about 1 to 60 miles in size, and it lasts anywhere from 1 to 30 hours. It's accompanied by lightning, thunder. It affects a relatively small area and is short-lived. And thunderstorms are always the product of vigorous convection that extends high up into the troposphere. Let's take a look at each of these stages in more detail, beginning with the towering cumulus stage. We've talked about how clouds develop. Cumulus clouds, all clouds develop from uplifting air that reaches its condensation point, the dew point, and we get clouds form, and cumulus clouds form from convection, updrafts. So if we have vigorous updrafts, we're going to get larger clouds, larger cumulus clouds, and the altitudes that we're talking about here are 26 to 33,000 feet, and they can develop very rapidly, 10 to 15 minutes. So you can literally watch these things grow. The convection that drives thunderstorm growth is free convection, which is simply intense solar heating of the Earth's surface. So the Earth warms up and warm air rises, causing updrafts and instability, and if there's moisture in the air, that will promote cloud growth. But free convection is generally not enough to produce thunderstorms, so we typically have some other type of convection at play in addition to free convection. Recall the different types of forced convection, which include orographic uplift and converging winds. Orographic uplift has to do with topography. So if there's a mountain or any kind of topography in the area that can force air to rise and encourage convection. And of course, if we have converging winds because of a weather system, again, forced convection. So the stage of the growth here is denoted by strong updrafts. And any water droplets and ice crystals that have formed in the cloud are kept suspended by these strong updrafts. So there is no precipitation at this stage in the cloud's development. At the mature stage, we have very strong updrafts that have pushed the cloud up to almost to the troposphere. Recall when we talked about clouds that cumulonimbus clouds can get an anvil-shaped head when they touch the top of the troposphere, the tropopause, and spread out. So you see these very strong updrafts here, and now we have downdrafts. So what happens is the water and the moisture are forced down because the cloud has kind of grown out as far as it can. It begins to spread out. And so this mature stage is denoted when precipitation reaches the Earth's surface. This is the stage of all the weather, the heaviest rain, the frequent lightning, the strong surface winds, and possibly even tornadoes. At this stage, the water droplets and ice crystals have grown to such a size that they can no longer be suspended by the updrafts. Gravity pulls them down. The downdraft is created when the precipitation descends through the cloud, and it drags this colder air from higher up in the atmosphere down with it. So this leading edge of the thunderstorm often resembles a little bit of a cold front, and you've probably experienced this when a thunderstorm cloud starts to become mature and you feel that downdraft. The downdraft is called a gust front, and it's this stage of the life cycle in the thunderstorm is denoted with ominous appearing low clouds. So here's a couple pictures of these ominous appearing low clouds. One is a roll cloud. This is produced from the gust front, sometimes, not always, and the circulation that ensues from that gust front hitting the surface. And then a shelf cloud, which is this little guy here. It's kind of like a skirt around the thunderstorm, again from the gust front. Here we see that thunderstorms can develop along gust fronts ahead of the main storm. So what we're seeing here are thunderstorms. Here's a gust front from some of these eastern storms. So this is usually not the way our weather goes, but this is looking at one thunderstorm. So here's our thunderstorm, and the gust front spills out here, and it can be strong enough to produce its own uplift. All that cold air pushed down to the Earth's surface can cause any existing warm, moist air that was there to suddenly rise, and so we can get thunderstorms that develop along the gust fronts ahead of the main storm. Finally, the dissipating stage is where the precipitation and the downdraft spread throughout the thunderstorm cell, and they bring the end of the storm. The subsiding air replaces the updraft and essentially cuts off the supply of moist air. So remember, adiabatic compression warms subsiding air, and so the clouds eventually vaporize, and the party's over. Thunderstorms are classified based on how many cells exist within the thunderstorm. If it's a single cell, so one cumulonimbus cloud, it's denoted by weak updrafts. These are usually not severe. They can be, but usually not. It's a slight threat. If there's multiple cells, which we usually see in a long-lasting thunderstorm, it's not that one storm is lasting so long, it's that there's multiple cells at different stages in their life cycle. So here again we have weak updraft, non-severe, or we can have strong updrafts. It just depends on the conditions. These are moderate threats. This is typically what we see during the monsoon season here, if it ever starts. The multi-cell line is associated with a front, typically, and we have a line of thunderstorms ahead of a cold front. So these can be, again, non-severe or severe. It's a moderate threat. And then the highest threat are what we call these supercell storms with very intense updrafts, almost always severe. There can be a mesocyclone, which we'll talk about a little later in this chapter, and these are very high threat. So let's stop this first portion of the lecture here, and we'll talk about thunderstorm classification in the next portion. Bye for now.